Welcome to the show, everyone. I'm excited to share with you today getting younger. It's going to be a great topic we're going to talk about. And I just want to warn you, if you're here because you're a listener of my show, awesome. We are recording this on video. So you can go to Flizanes.tv because I'm going to have a great conversation with Dr. Kara Fitzgerald today. If you are searching Dr. Kara Fitzgerald and you have found this, I just want to let you know this is my show. And what that means is I'm going to talk. It means I might have stories. I'm going to have questions. I'm going to have my own point of view to share with. So if you don't like me, totally cool. So if you want more of just Dr. Kara, where can they find more of you?
They can, if they want to go to the book and just learn all things book and app. We have the book in an app at this point, youngeryouprogram.com, or they can find me and my clinic and our blog and podcast, etc. at drkarafitzgerald.com. So drkarafitzgerald.com. So those two sites.
Excellent. All right. So today we're talking about younger you, reduce your BioAge and live longer and better. Now, I'm just letting you guys know this is, if you're watching on the video, this is a huge book. Okay. And I would recommend getting it, even if you buy it on audio, because I have it on audio also, because you're going to want to reference some of the foods in the back, some of the protocols in the back. There's a ton of links. There's a ton of references. So you want to get the book first and foremost. And I'm looking forward to, there's so many things to talk about. She's probably going to have to come back. So if you're watching this and we don't cover all the things you want to know about, please make sure to send me an email or contact me in any way you normally do to let me know what else you want to talk about. So first, let's start a little bit with your story, Dr. Kara. I just want to know how you even got into this work and let people know sort of your passion and focus and why this way of studying medicine.
Why thinking about epigenetics?
Mm-hmm. Okay. Well, the whole thing, like, how did you get here?
How did I get into functional medicine? So quick, super down and dirty story. Was raised with a mom who was savvy towards health, amazingly. I mean, we were raised with some exposure to organic foods. I mean, and back then, if you wanted like organic flour, et cetera, you had to get in the mail. We would have big packages arrive from Walnut Acres, but we had a big garden and we took brewer's yeast, the things that were hip back in the 70s. My mom gave to us, and it made me aware of it. You know, we made our own yogurt, stuff like that. But I also ate some really horrible food too. And I promised I would rebel. Like, a really funny story was opening my lunchbox in school one day and clearing the table because my mom had given me a sardine sandwich, you know, on this thick, homemade, like crunchy wheat bread. And it smelled so bad. I just cleared the table and it was mortifying. I went on to, you know, threaten her. The big threats in my family were like, I'm going to eat a whole package of Oreos, things like that. But I had gotten some really foundational, important information from her. And so when it, you know, flash forward many years later, and I'm thinking about medical school, I became sick with kind of classic chronic fatigue, probably started as mono Epstein-Barr in my 20s, and didn't get better after going to many doctors until I saw a naturopathic physician here in Connecticut. And that was life-changing for me. He got me better with very simple tools. CoQ10, he did some botanicals. He tweaked my diet in the most basic way. He had to like meet me where I was at. And I was just in my early 20s. And I got better. And it was just at that decision point time that it seemed going to naturopathic medical school, you know, absolutely made the most sense and resonated with me the most deeply. I am a nutritional biochemist nerd. In fact, I ended up in a laboratory doing postdoctorate training in nutritional biochemistry. Otherwise, I think I would have probably ended up going for a PhD. But anyway, that opened me ultimately, was sort of the first step into why, as a clinician, as a naturopathic physician clinician, I would even be thinking about epigenetics and writing the book that I wrote. So, you know, naturopathic medicine plus nutritional biochemistry and laboratory science kind of made me where I was, with a foundation from a savvy mom.
But you start out in functional medicine, and then, but you didn't have, I mean, I feel like this is a niche of a broader sweeping, you know, functional medicine overview, right? I mean, because now we're focused on BioAge, and how did that come about?
Yes. Okay, good. That's a good question. So thinking about gene expression. So biological age is measured by looking at what genes are on and what genes are off. That field is called epigenetics. So when you hear me talking about epigenetics, it's epi above genetics, the gene. So it's the biochemistry that regulates turning genes on and off, allowing them to be turned on and off. And the way that we measure our biological age, chronological age being the number of birthdays we've celebrated, biological age is how fast we're physically actually aging. So two really different ways of looking at age, and BioAge is infinitely more important. And we measure BioAge by looking at gene expression. I got into epigenetics probably around 2013. I started to read the literature on it, and most of the science coming out at that time was looking at cancer. And cancer very efficiently, so the tumor microenvironment very efficiently hijacks gene expression, takes gene expression from us, turns genes on that will push cancer forward, turns genes off that inhibit cancer. So it just takes over our own epigenetics for its own sort of nefarious growth. And the question when I was reading the literature at that time was, how are we influencing it in functional medicine? Are we doing any harm, given that cancer can take over our gene expression? Questions like high dose B vitamins that can alter methylation. If somebody has cancer, could that be a problem? So these were questions swirling around my head at the time. And I talk about it in the book if you want that backstory and what I concluded. But the take home is we designed a diet and lifestyle program. So we decided a diet very focused in methyl donor foods and we can define that. So we designed a diet to optimize epigenetic expression safely. That's ultimately really where we landed. And then we also included lifestyle factors that influence epigenetic expression or gene expression: exercise, enough sleep, some stress management. And we packaged that and called it the Methylation Diet and Lifestyle. And we started to use it in clinical practice. Let me say, and JJ, interrupt me at any time if I'm going on too long or if you need to define anything. Of all of the epigenetic marks that regulate DNA expression, certainly methylation, DNA methylation is the most studied, and it's arguably the most resilient. And so our research is around DNA methylation. There are other processes that are happening that influence gene expression as well. But DNA methylation kind of leads the charge, at least in the science right now, although the others are important as well. So we designed a methylation diet and lifestyle with an idea that we were optimizing genetic expression. We released a book to professionals. I lectured on it. Actually, people were quite interested in it in the functional medicine world. So small pond, but I lectured on it around the world. And then eventually we were given in 2017 an unrestricted grant to actually study it. So we thought we were influencing gene expression, but the only way we would be able to tell is by conducting a research study. And Metagenics gave us a full unrestricted grant to see what we were doing. And it was in this study, which was a small pilot study, randomized control study, where we were able to see. So one of the first pieces that we looked at was, again, looking at epigenetic expression, measuring biological age in our study participants as compared to controls. We were able to get them biologically younger in looking at gene expression patterns. So it was just kind of a huge finding, and it led to being given a book offer. It was kind of a big deal. It was the first time that this had been demonstrated in this type of study. So rather amazing.
Well, congratulations.
That's the backstory.
Congratulations. And that is amazing. And I want to outline for those that are listening. So I've talked about epigenetics about, 4 or 5, 6 times on the show. Bruce Lipton's been on twice.
Okay.
So yeah, and he's coming on again. So we talk about epigenetics, but I talk about epigenetics from a sort of a little broader perspective of more quantum physics and more interpretation and emotional, vibrational frequency more than what we're going to talk about. And I just want to set that tone for people and I do want to talk about that with you too. because there's in my, I've come from the place of a very strong intuition about certain knowing things. I make the joke that and I even told Bruce his first book, Biology of Belief, I didn't need to read it because I'm like, yeah, your beliefs create your biology. I don't need to know anymore. I know this is true. I don't need to be proven it. I don't need studies to show me this. It wasn't an arrogant, like I know what's in the book and I can explain it scientifically. No, it just means that I understand I understand it and I believe it. I know it. I know it 100% in my body. It resonates so deeply that quickly I don't need any proof. And what I love about what you're studying is that you're giving proof to things that people kind of intuitively know, that we should eat certain ways and that stress is bad and that, right. And I love, and it's not because I want to go out and yell at the people or try to prove to the ones that aren't interested, but it's the ones that are on the fence a little bit about how, is it really, I see somebody over here who eats like crap and they live to 90. I see someone over here who ate perfectly and they were a triathlete and they died at 50 of a heart attack. So I want to talk about DNA methylation in the food and the lifestyle. And at the end of this, just because it's my specialty, I want to go into it a little bit more because I remember the study that you were citing, or the when you conducted with the twins, and the twins that both had cancer, I believe, and one had their toes painted and the other one didn't. And I'm in the background thinking I would have loved to ask them how they interpreted certain things in life differently, like take it to, I don't know if you did that, but you guys were looking at experiences
This wasn't research we conducted. This was, this was a publication from elsewhere. Yeah.
But it was like all the different layers and levels. And while I spend a lot of time on emotions on the show, frequency, vibration, quantum physics, law of attraction, emotions, how emotions affect disease, how emotions create disease. And we can talk about the biological embedding because I want to hear that from your research. But I want to spend the majority of the time, we'll end with that, but I want to spend the majority of the time looking at the things that I'm not talking about when it comes, and the whole idea of the aging. I'm looking at it from emotions, like with Dr. Nation, the cancer patients and the cancer doctors, like looking at the patterns that people have and how their body's responding to that overarching feeling, frequency, tone, belief system, interpretation that they're under in that bubble, and how their body responds to that, and how, we're going to come in with some physical things, but sometimes the physical things don't change their outcome because we haven't addressed the container that they're in and that sort of frequency that drives everything, or that allows them to accept what the changes that they're making, or rebel and say, well, you're doing the right things, but the body's not accepting it. It's not actually changing. So I want to look at what your studies have shown, and the foods and the lifestyle and when it comes to reducing BioAge. But I want to start off with methylation and how you really explain that in a dumbed down way, so that because you use it a lot in the book, and I just want to make sure everybody, including myself, could repeat that back and understand it so clearly that there's no question.
Yeah. Okay. So methylation, as I mentioned earlier, is a chief way we regulate which genes are on and which genes are off. So what is methylation? We've got a methylation cycle in the body where we're making these little methyl groups. A methyl group is just a carbon with 3 hydrogens. It's an exquisitely simple molecule. Carbon and hydrogen are ubiquitous. I think we evolved to use methylation a lot all over the place. So there's hundreds of methylation enzymes. There's lots of ways we use methylation in the body, basically in every cell, pretty much all of the time. And it happens to be a chief way we regulate gene expression. So in the book, I'm really talking about gene expression, but I do mention that we have a methylation cycle in the body that's kind of worrying, pumping these methyl groups out. And it's possible you've heard of the supplement S-adenosylmethionine, or SAM. Sometimes people call it SAM-E. That is our universal methyl donor. So sitting on that SAM molecule is a carbon with 3 hydrogens. And this whirs around in the body wherever it's needed for all of the myriad methylation reactions, and it donates that methyl group. And then we recycle it in the methylation cycle.
Can we, I want to stop you because I still want to I want it even more in my mechanical brain. When I studied exercise physiology, it took me so long. It's because of the way that it was drawn. And when I don't know if you know physiology, like Adam years ago, I mean, this is talking 1995, there was a computer program called Atom, and it literally showed mechanically, and it had pictures and it had colors and it had animation to describe all of the chemical and electrical reactions from action potential to muscle contraction, because my background is as a trainer. And so rather than taking physiology and then like memorizing steps with words on a piece of paper, what was really clear for me was to be able to see that chemical and electrical reaction, all those different processes from the moment that I have the thought of lifting a pencil to all the way down to the chemical and electrical muscles that need to be activated in order for me to lift the pencil. So what I'm hearing, methylation, is it like oxidation and antioxidants in a free radical kind of method, or can we break that down a little bit, even just a little bit more?
It is, I mean, I guess you could think about it kind of like a free radical reaction in that, so in the methylation cycle, we take the amino acid methionine and it's converted to S-adenosine methionine. So, and S-adenosine methionine, it has the carbon and 3 hydrogens on it. It's ready for donation. So we get the methyl group from methionine, an essential amino acid that we get when we eat mostly animal protein. And then it's converted to S-adenosine methionine. And then SAME's got that carbon and 3 hydrogens on it, and it leaves and is involved in reactions all over the body. Like we use it, for instance, to make dopamine, or to eliminate adrenaline, or to transform estrogen, or to detox the body from myriad other compounds. And then we also use it in DNA. We use it to make certain fatty acids that are in the lipid membrane, like phosphatidylcholine and so forth. Acetylcholine, actually going to muscle contractions. Acetylcholine requires actually about 3 steps, I think, of that SAMe compound. So 3 methyl groups. It's actually, it's a pretty demanding product to make. So methionine is converted to S-adenosine methionine. The byproduct of that, so once the methyl group is donated, it becomes S-adenosine homocysteine, converted to homocysteine. We know when that's very high, there's problems with the methylation cycle. That's also associated with increased cardiovascular risk, but it's a key player in the methylation cycle. And homocysteine is converted back to methionine using B12 and folate, or the compound betaine, which we get in beets, but we can also produce endogenously. So homocysteine then gets recycled back to methionine, and methionine goes on to make SAM again, becomes SOG, homocysteine, and cycle goes. So yeah, does that help? Does that visual bring it up a little bit more?
A little. I guess I'm trying to, let's take it. I want to break this down, because if I don't understand it, then I don't know if I can communicate it, if everybody else is going to understand, if their brain.
The cycle is in the book. The cycle is in the book. And if people want to see it, they can certainly get the book. But if you just Google methylation cycle, you can get a visual on the cycle, the production of SAMe, and then we created a super simple version in the book in the resource section.
So to give you an example of that mechanical understanding. So methylation, is it a byproduct? Or is it so we need enzymes to break down food, and sometimes we don't.
So the methylation cycle simply produces the molecule S-adenosine methionine. It is a cofactor of the enzyme. So it's a needed component of the enzymes to allow methylation to happen. So once SAMe is produced in that methylation cycle, think of SAMe like you think of the B vitamins, or like you think of minerals. All of those are cofactors to be used in biochemical reactions. So they're cofactors accompany enzymes to allow the reaction to occur. So like a B vitamin, S-adenosine methionine works with the methyltransferase enzymes. There are over 300 of them. So SAMe is that cofactor produced in the cycle, is the cofactor with the methyltransferase reaction that allows the methyl group to get placed where that enzyme is dictating. So for DNA methyltransferases, that methyl group is being taken from SAMe via that DNA methyltransferase enzyme and placed onto a very specific region of DNA.
Okay.
Is that better? Does that bring it alive a little bit more?
Yes, you were talking about, so knowing that we need certain minerals, we need our B vitamins in order for the processes of our body to take place, basically. So the question becomes with methylation, being the process and needing this is that the foods that we're eating, because we all understand on a very basic level that if you're not eating the nutrients your body needs to make your pupil, right? If we're not getting the amino acids and to make your, different parts of your body, then the body's not going to be, it's going to try to replace it, but it's not going to be as optimal as having what exactly you need to make it chemically in your body, like having cholesterol to make our hormones, right?
Yeah. Mm-hmm.
Okay. So this is a process that we should care about, methylation. I mean, Dr. William Davis and I have talked about it too, in terms of digestion in his book Super Gut. So, but again, and I didn't really challenge the term because at the same time, I also know that people by this point, I'm gonna have to say, hey guys, like just stick with it. I'm just trying to make this really clear for you. Don't get bombarded and overwhelmed with all the scientific stuff. I'm trying to make it clear so you understand why you should care. Now, ultimately, why they should care doesn't matter what the science is in that. It's that that what you eat, how you live affects your BioAge, which affects your disease profile or not. And right. So that's the basic, but I'm the nerd that wants to know like how an antioxidant works and why we want to take it. Like that oxidation is a natural byproduct of things that happen in the body. So that's all. I just wanted to, because you say it a lot in the book and I wanted to get really clear, and maybe it's not really clear to everybody else, but that's why.
The methylation cycle is separate from what I'm talking about in the book. Like, I mentioned the methylation cycle, but predominantly what I'm talking about in the book is when a gene has a lot of methyl groups on it. And in the scientific literature, a methyl group is always, when it's related to genes, looks like a red lollipop. It's just a little red ball and a stick. And if you can imagine, double-stranded DNA, and there's this is the base cytosine. So in the fifth position, if you want to get very granular of a cytosine, when it's sitting next to a guanine, so it's called a CPG, that little red lollipop can be placed. So think of a strand of DNA and one discrete gene on the strand, and there's a bunch of red lollipops, there's a bunch of methyl groups. That gene is not able to be turned on. It's not able to be sort of opened up and transcribed.
Got it.
Those lollipops can be pulled off, or we can inhibit the placement of those lollipops. And so when there's an absence of the lollipops, that gene can be on.
Perfect.
So it's just, think about it. Lots of lollipops, they just get in the way. They just block. Lots of lollipops in the way. Few to no lollipops, gene can be like popped up and on.
Perfect. So now everything we talk about is what's going to help you take the lollipop off and keep the lollipop off, right?
Or put it on. No, we don't want. No. It's actually very nuanced. We want good genes on. We want bad genes off. We can keep it super simple. It's not. We just want to get them all off. No, we want to have them. We want to have methylation happening where it should be, and not happening where it should not be. So good genes on, no methyl groups, bad genes off, lots of methyl groups. That's super simple, but yeah, think of it that way. And so we need to balance. So this is balance. If we only wanted, to put methyl groups on, we could just push methylation really hard, but instead we want to eat to balance it.
Okay. Well, let's start talking about where you started with this in terms of some of those, whether it be diet, you said you put together a diet, and I was reading and listening and, and I heard certain inflammatory foods come like later, removing some of them. But in the beginning, there was I was hearing all kinds of different foods. So it didn't feel like you were specifically, regimenting everybody on the same program, or you weren't eliminating complete food groups necessarily, or kinds of foods. Right. So can we talk about that?
Yeah. Okay. So the two components. So thinking again about wanting, the methyl groups to be where they're supposed to be and not be where they're not supposed to be. We want really two fundamental components. We want to be eating. We want to have enough we want to keep the methylation cycle whirring. So we want enough methyl groups, but we also want to sort of direct where they might be landing. We want them to go into the best possible place. So there's two groups we think of, and we call these epinutrients because these foods influence epigenetics. They influence DNA methylation. The first group of nutrients that were packed in are those that have that influence methylation cycle. So these are, we call them methyl donor nutrients. These would be the green leafies, all of the fabulous green leafies. These would be seeds, some nuts. This would be shiitake mushrooms, inaki mushrooms, some of our, really good nutrient dense mushrooms. It's eggs, if you can eat eggs very rich in these methyl donors. Ideally, people are having a few servings of liver a week if they are not vegetarian or vegan. Liver is a methylation superfood. It's a multivitamin mineral in a food matrix. It's super important. So these are examples of what we call methyl donors. And then we've got that SAMe, so we've got the red lollipops, and now we want to say, hey, red lollipop, go here, go here, go here. So the traffic directors that are going to move those red lollipops, we think, to the ultimate, to the most important sites are what we call DNA methylation adaptogens, but in fact, they're well-known polyphenols. So they're well-known plant chemicals that all of us are probably eating in our diet. I'm sure we're all eating some of them, whether we know it or not. Super famous ones that we think are wildly important include green tea, EGCG from green tea and the other catechins, quercetin, luteolin, resveratrol, huge curcumin found in turmeric. And there are many, many, many other plant chemicals. Cruciferous veggies have really important ones like diindolylmethane and sulforaphane. So we want to be bathing our genes in these two nutrient groups, methyl donors and methylation adaptogens, lots of them. There just so happens to be a lot of foods we can eat to get these, and therefore the diet is actually really pretty broad, and I think relatively easy to do. In fact, we created a nutrient appendix of these. It's the first of its kind appendix, I think, and it's 30 pages of these epinutrients. So all of us can find things we like. The diet is low in sugar. It's lower in carbs. It's keto leaning. So it's not a powerfully low carbohydrate diet, but we think our study participants were in a mild ketosis, just judging by their the drop in their triglycerides. There's a gentle intermittent fasting prescription. We weren't studying intermittent fasting, but we put a 12-hour eating window in there. There's in this 8-week program, there are no grains, no dairy, and no beans and legumes. But later in the everyday version, you can add beans back in. You can do a little bit of dairy if you tolerate it. I am not anti-legumes by a long shot. I think they're really important, but some folks don't tolerate them. They get gas and bloating. And they also, when people aren't metabolically flexible, they can cause a spike in sugar. So for those reasons, in this 8-week intensive, we pulled them out, but then you can bring them back in after that. And so those are the foundational dietary pieces. Let me stop there and see.
What about liver? I know I have the ancestral brand of the cartilages and the bones, and then of the liver and the organs. Yeah. Would that be a nice replacement if someone is? Okay, good. Because I'm not
totally. I'm like, where's mine? I usually have some on my desk. Actually, it's over there. But yeah,
no, mine's in my kitchen.
Absolutely, you can absolutely do liver caps. I have a resource section in the back. Ancestral is a great brand. You could do that. Yeah, you can take like maybe 3 a day, and that will end up being the serving recommendation that we want you to get. So if you're just shying away from liver, it's gnarly, you could definitely do it in a clean source cap.
Well, I just remember as a child being served it and thinking, forget that it was liver, but it just smelled bad. I didn't. And now, of course, my taste buds have changed, but I think just psychologically, I can't do it. I'm happy to take the pills.
It's the funniest food. It's like, it is. It's an emotional food.
It is. Well,
it's entirely offended that it's in there, or
I mean, I understand it's deep nutrition about it, right? Eating nose to tail. I understand all of the epigenetic indications of having all these parts and pieces that we once had that we don't have anymore. But I just can't bring myself to cook liver and
now we have
look
caps.
At it. Now we have the caps
for like the modern.
Totally. Thank you for bringing that down to a powder so that I could, because when so I'm really happy about that. So, okay. So then you did this, and when you started your clinic and then you kind of started the study for BioAge, were you having the same kind of common ailments and diseases and complaints and patients that we're dealing with the same thing, because it almost feels like if someone didn't know, like the book and Younger You feels like the whole point was to sort of reduce BioAge for youthfulness, not necessarily for disease prevention or healing of a disease or a chronic condition. So what was the
let me speak to that.
Yeah.
That's such a good question, and I didn't actually bridge it in the beginning. So our entry into thinking about epigenetics came from my read on the cancer literature. So that was like the first thing. As I said before, cancer takes over where those red lollipops are going. So maybe it's a little clearer to people. It very efficiently takes it over so that it grows and you die. Turns out that aging is like that. So aging is the number one risk factor for all of the chronic diseases. So for cardiovascular disease, for diabetes, for dementia, for cancer. Aging is a bigger risk factor for lung cancer than is smoking. So just to give you context, aging, and so when you look at the level of epigenetics, what's actually extraordinary and why we looked at BioAge and started to think about reversing BioAge or changing BioAge is because aging looks, where those red lollipops are, like these chronic diseases, like cancer. So genes that you want on are turned off as you age. Genes that you want off are turned on as you age. It's such a raw deal. And because these changes occur, we become at increased risk for all of these chronic diseases. This is a big foundational piece of the puzzle. There's a complex cascade going on beyond that, but this is a foundational piece. So even though we started thinking about cancer and we brought it in our practice with that piece in mind, we quickly saw that it could have the potential for influencing biological age. And if we can favorably shift BioAge at all, we can reduce the risk of all of these chronic diseases simultaneously. So the power of this thinking, instead of addressing disease here, siloing everything, but to just go in there with epigenetic expression, thinking about gene expression, the potential of benefit for lowering BioAge in this safe and sort of affordable and a broadly adaptable way, the potential savings and sort of empowerment are they're just astronomical. There was a study done last year looking at the economics of very modest improvement on BioAge, and it would save this country trillions and trillions and trillions of dollars. So like one better year, so an improvement in health span would save like 38 trillion in the US. If you could do 10 years, it would be an order of magnitude, so $380 trillion. So the cost savings of thinking about improving BioAge is just extraordinary.
What was the study done? Because I'm like going to jump out of my skin right now of excitement with the fact that the whole aging thing, because my brain goes to what is the common denominator for me emotionally for people as they age? Well, they normally don't spend a lot of time being conscious about any interpretations they've had about any of their past traumas or their relationships. And as we age, we get stuck in our ways, fear comes up. And I see the difference between someone who's aged. Like I had two clients once, they were both 94, and one of them had a lot of emotional, dramatic losses and things. And the other one also had some losses, but she was extremely involved and conscious and aware of her emotions and working on herself. And she was doing push-ups and kickboxing with me as a trainer at 94 versus the other one was bedridden and in her recliner. And the exercise we were doing was literally like how to get her out of the chair and to walk 5 steps.
Yeah,
but if I look at from my vantage point,
that's same chronological age, very different BioAges, but yeah, go ahead.
Well, so I look at it as the two pieces of there's the physicality and the environment of what they're doing. And then there's also the emotional expression and interpretation of their outlook on life and how one felt empowered and excited about life and passionate and still living every day at 94, excited about living. And the other one was waiting to die. And so when I look so to me, I'm like, oh, can we do the study on just the emotional piece to see how that interpretation, that view of the world, that like when you mentioned lung cancer, and that aging was a bigger risk factor for lung cancer. And I'm thinking because lungs are where we hold grief. And if someone over time loses people and they hold that grief within their lungs, to me, I'm like, that's why Christopher Reeve's wife got lung cancer, as far as I'm concerned, is because of the grief that she held. She never smoked a cigarette, but she had lung cancer. And why? Because of something she drank in her water? I don't know. She had a lot of grief. So anyway, I'm just fascinated by the fact that you said that aging has go ahead.
Yeah, so I have two thoughts on that. And so the first one, I would just underscore huge that that's what you just said, those two very different women, same biological age. There's no doubt in my mind, if you measured them, they're, same chronological age, both 94. But if you measured their bioages would be wildly different. And the one who's exercise being one of the most important and potent anti-aging elixirs that we have. In fact, when cancer takes over and shuts down genes, we know those very same genes can get turned back on by exercise. So those protective genes can get turned back on with exercise. And they also can get turned back on by some of the phytochemicals that we prescribe, like green tea and curcumin, et cetera. Exercise is just radically and wildly important. The emotional piece is pertinent here. I mean, I won't claim to be able to speak. I can't speak elegantly to all that you're positing, but what I can say is emotional trauma is stored in DNA methylation patterns, does change gene expression, and will give rise to not just sort of insufficient access to oxytocin or some of our feel-good hormones, but also increased inflammation, metabolic changes, and increased risk for the chronic diseases. So emotional trauma that influences gene expression, because not all of it does, but some of the intense stuff will, without question. This emotional trauma can absolutely show up there and then influence the chronic diseases of aging that 94-year-old woman stuck in her chair was experiencing, much more so than the other. So yeah, emotional trauma can definitely play a role there. There was a really interesting study that I talk about in the book, about the cyclic and damaging nature of negative thinking, sort of the loop tape of negative thinking, and how that can have epigenetic or gene expression underpinnings, and it will just create this loop tape. Fortunately, the literature also suggests that we can make some changes and change gene expression favorably, so we don't need to be a victim of our past trauma, even as far as gene expression goes, that we can change gene expression. And our study definitely showed that we can do it in a relatively short period of time.
Well, that's the biological embedding, right, that you talk about in the book? So the translation of psychic experience to DNA methylation. So psychic experience to biochemical changes is called biological embedding. So you're embedding that experience into the epigenome. Yeah, it's amazing. And I'm in a field that. Or I'm creating one, I don't know, that it's like the hardest thing. Diet's easy. People are like, oh, tell me what to eat. Sure, I'll eat something different. But the emotional piece, which is the hardest piece because it has to deal with pain, and most of us run from our pain and do everything else we could possibly do. So in order to not sort of face some of the fears that we have and to allow ourselves to express the things we've been holding on to, which, again, ultimately, but I do love that there's still all this physical stuff that people can do also, and that may be enough, like with you and with chronic fatigue. You just tweaked your diet and boom, and you were better. So my position
I did make some lifestyle changes, though. I definitely did some stress reduction, and there were other pieces in there too, for sure. Yeah, for sure. Okay. I think the lifestyle piece is really essential. No doubt.
So, well, let's talk about the besides the foods. Then again, this is why everybody wants to get the book. Even if you listen to audios and you want to listen to the book, you're not going to get. It's just easier to have the book to look at the grocery list and the recommended diet and the menus and the foods, and just easier to have the book. But let's talk about any of the other key factors that anyone listening to this right now can change without even getting the book. So, some things that we found were really easy and simple.
Yeah, we want you to be getting enough sleep. So if you're not sleeping enough, you're definitely increasing your risk for all of the chronic diseases. You're pushing, you're turning up the volume on biological aging. So you're going to get older faster if you're not sleeping. And we see that these changes happen at the level of DNA methylation. So it augments gene expression. And conversely, so people who don't sleep are biologically older. Conversely, if you start to sleep, you can see improvements, and there's evidence in humans and in animals. So sleeping is really important. Taking stress very seriously. So this, I think, in part would come back over to doing the work that you're talking about, is essential. So stress, I mean, we see, as I said before, we can inherit stress patterns from our ancestors, from our immediate past generations, and even further. Early life stress experience can influence DNA methylation. Current stress, total stress, can definitely negatively influence DNA methylation. In the particular way that we measured BioAge, we looked at 353 different sites on the genome, and 25% of those are influenced by glucocorticoids. So by cortisol, by stress, they influence what's going on there. So to me, that reads like stress is one of the biggest variables in the aging journey for that piece alone, but there's plenty of other evidence that I cover in the book. So we prescribed a twice daily meditation practice. That's what we used in our study. And if you want to follow the study verbatim, do that. But there's plenty of other ways that we can de-stress and that have beneficial changes to the epigenome. So can make us biologically younger. Yoga, Tai Chi, again, meditation. And, you don't have to be a guru. You don't have to retire to the monastery and become a monk. Even single experiences of yoga or meditation can have favorable changes. It's actually pretty extraordinary. But the more you do it, so the more consistent you are, the more you adopt these habits for the long term, definitely the better.
And let's start by telling everybody where to go. You can actually take a biological age self-assessment, right?
That's right. Yeah. So we call it the BASA for short, biological age self-assessment. And you can get that at youngeryouprogram.com/BASA. You can go right to it and fill it out. It's easy peasy. It'll take a couple of minutes, and then we'll spit you out a form that gives you your BioAge based on this intake, and you can look and see what you're doing fabulous and where you can tweak. And I will say, I know we were talking about my treadmill desk over there. For me, sitting too much, especially doing these interviews where I have like my lights are set up right here, is one of the things that's adding some time to my BioAge. So I get over there as much as I can. I have a meeting actually coming up here pretty soon, and I'll hop over to that meeting because it doesn't require looking glamorous.
I did see on one of your Instagram videos that you were walking. I thought you were outside, but now I know you're probably at your desk.
My treadmill. Yeah.
right.
Yeah.
All right. So that link will be in the show notes below this video, or in the show notes below when you're looking at the podcast or when you've downloaded it. So youngeryouprogram.com/BASA. Okay.
Yep.
And as well as drkarafitzgerald.com, and anything else you want to leave our listeners with? I mean, I would love to have you back. There's so many more things to talk about.
Yeah, we have a lot more we can talk about. If you go to drkarafitzgerald.com, you'll find all sorts of blogs and podcasts and yada yada that will dive into this. But the youngeryouprogram.com, you can get BASA, and you can also get access to the app. So if you want a little hand holding for this journey, do the app. For sure. The app will the nutrition team that we used in the study are like in there living in the app, and you can find them there. But everything that we did in the study, including the lab tests we used, you can access through the app.
Awesome. So get your app, get your book, get your test, and we'll meet back here at another time. Please send me any other questions that you have for Dr. Kara so I can ask on our next conversation. And thank you so much. I mean, I hope this has inspired everybody to know that you can just make some small changes to make big differences to start. And then, of course, when you get the book, you can even follow the diet plan and start to see changes in your health immediately. That's not going to cost you a lot of money.
Yeah, that's right. Thank you so much, JJ. It was great to hang out with you today.
Thank you.